Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. That information is not available.
Oh no! Welcome to a number 10 Encoder PCB mounting. Let's get on with it. So what we're going to do today is we've got this sorted last time. I reprinted that out on the last stream. Well, I designed it this morning and reprinted it out, and it works okay. And I've fitted it to the actual device, so we could have a look at that, I suppose. Let's have a look at that. Let's just make sure audio is good as we've got last time. Yeah, audio is good. Right, here we go then. So we've got it here. So I've gone ahead and attached the magnet to the bottom of the shaft, so when you turn the shaft it turns the magnet. Okay, so what I've got to do today, if I can stay up a little bit, well, an hour or so, mount the PCB. There's the PCB. It's got to be suspended above the chip, so many mil away, and it's got to be mounted to this chassis. And then we also would like to make that chassis, or that bracket that holds it, part of the base to seal the belt up from the elements, so as well as can be. So anyway, it's never going to be like that, but I mean, we're going to have a go at it. Alright, so anyway, let's just get on with that. Okay. Right, so we've already gone ahead and modelled the PCB, and I've put it sort of where it wants to be. Might be able to go a bit closer, but there is up and down play here, so we've got to encompass it in something, maybe. That's the biggest headache. Putting that there. Ideally that would want to go up the top, but up the top is where the area, well, where the pole gets attached to another pole. Anyway, so let's start off with something. So we've got existing holes and fixings around here, so it makes sense to attach something to the other side of this. So what we'll do then, we've got the belt that comes through here, so we've got to be careful of the belt. The belt sort of feeds through this gap, round there and out the back of here, hence the gap. So whatever we do, we've got to fasten off it. Now I could fasten off the sides instead. So I'll tell you what we'll do, we'll turn it upside down. You can better work on it upside down, that's better. Right, so there'll be some juggling around with this eventually to get this more compact and ergonomic. It was developed a bit at the time and it's expanded. We didn't really take into account what we were going to use at the time or how we were going to do it, so because we've got a wider teeth wheel here than there, we can't put the magnet over here because we'd have to count it round and round and round and round. So we've put it on the end of the shaft where the angle 0 to 360 degree actually references to the shaft position. If you did it on there, it wouldn't reference it. You'd have to count how many times you've gone round, all this kind of stuff. This way we can just do it like that. Okay. Right, so to start with, we need something for the PCB to sit on. What we might have to do in the future is lower this down. Oh, you can't. Yeah. No, it's got to go there, the belt has. So you fix the belt, so this is fixed in position. Anyway, so what we need to do is either draw something. Tell you what we'll do, we'll draw something. We'll go from here up to, I don't know how far yet, so I'll just go up to let's say 50 mil. We'll go across, go over here. Hang on, if I can get over there. So we'll just come up with that, I think. Come up with that there. We'll just go up 50 mil. We'll join them two up. And we'll probably have to draw from there to there. Right, that gives us a surface. And it'll probably have to be that size as well. So let's just do that size as well. So we're a little bit high, so that's okay for now. We can sort that out. Are we going to go all the way to the edge? Possibly. Yeah, might as well. Let's hang on. Let's just have a quick look. Do we need? Yeah, let's go to the edge. Let's go to the edge for now. Okay, so we're all. Oops, we're on the wrong tool here. Right, so we've got that bit there. Now we want a surface. We'll manipulate the surface later on. In fact, that probably doesn't need to go all the way, but I think we will. Right, so let's just start by coming out towards here. I don't know how far. I'll just do this, and that'll give us our surface. And we want some thickness again, so probably be, I don't know. Let's see what that thickness is there. Keep it all the same. 2.5, yeah, it should do. Minimum 2.5. Okay. So we've got that. We can get rid of the gap there. Oh, the joint. Get rid of the joint. So I'm going to 3D print it in one. Right, now it's too big. So I suppose we ought to just measure. Hang on. I'll tell what we can do. We'll bring that in, and we'll use that as a guide. That's it. Oh, it's not quite covering it, but yeah. Okay, and we need to raise this up off the deck to allow for any rainwater to go away. So that's going to be the problem with this. We might have to solder wires on this and spray it with a lacquer, or dip it in a lacquer once it's mounted, to make it, give it a conformal coating, so we don't have to, yeah. So anyway, so what we'll do is we'll grab the hole centers off this. I'll take the hole centers off this. I'll copy them off there. Paste them in place, and we'll push them up onto the surface there. That's it. And we'll have to come back round now. We'll cut them off. No, we're not going to go. Yeah, we don't want to go through it. Although we could go through it, but we don't want to do that. We'll just make this all part of the same thing. So we want some. Let's cut it. And oh, we're already on there. Paste it in place. That's okay. Right. So we're actually already on there. Let's just measure it. 3.3. So we need a stud, so that'll be the middle bit. Now let's make it right. So we want 2.35. I think it is 2.35. No, hang on. So it's not that. Right. Stop that a minute and just get the calculator up. I always forget this. I should write this down really on a little helper key piece of paper. So 4.65 divided by 2.325. So we want 2.235 all the way around. 2.325. Okay, so we can get rid of that bit now. No, that was the wrong one. Right, so now that's the inner bit, but what we need is an outer bit, so we're going to have to go off it a bit, so you need to get some thickness. Let's say it's don't know, let's say it's what? Let's just say it's 2 mil. 1.5, what's that like? That'll do, yeah. 1.5 wall. 1.5 millimeter wall, right. And I need to bring this up. So we'll bring that up 5 mil. 5 mil. And 5 mil. And 5 mil. Okay, so now we need to work out how far it is from there to the top of here. 3.655. So then we'll grab that there, move it down by 3.655. Or was it 665? No, it looks like it's right. Yeah, that's okay. Right, so we've got that. I need to be the other way up now. The correct way up. So, obviously we're going to put some brass pins in there. I don't think we need... It's a tiny little board. There's the board. So I don't think it needs... I think we'll save... We'll put 2 brass pins in. Yeah, 1 in each corner. Brass inserts, sorry, not brass pins. So we're going to get that now. How can I find that brass insert now? Need to copy it, so X-ray mode. There it is. Can I just grab that? Yeah, got it. Alright, copy it. Paste in, paste. Right, so we're the right way up? No, we're not. We've got to turn it round. Let's turn it round. That's it. So that'll fit over there. I haven't given this board a name yet, have I? No. We need to make some new layers, so I need to call it what it is as well. Has it got the name on it? I can't remember the name now. Oh, it's on the thumbnail from yesterday. I can't see it, they make the writing too small. Anyway, let's give it so I'll just call it Encoder PCB. Oops, PCB. Encoder PCB. There it is. No, it isn't. There it is. And we can turn it off now. Grab this. Grab it from the center in X-ray mode. I need to go over to this and put one in there and make a duplicate. Grab it again from the side if we want. Not as easy as it looks. Right, so I'll grab a copy of that. I'll put one over here. What's it doing? It's playing silly buggers. Right, so we've got one in each corner, and what we need now is a little bit, put one there and we'll have a bit of a stud sticking up here. So a flat area with a pin. Right, let's come out of X-ray mode. Right. It's awkward when have I got this into a... Oh yeah, no, I haven't quite got that complete thing. Yeah. So that needs to be part of that. So cut that. Paste that in place there. So we can get rid of that. Okay. That hasn't got, so what are we going to call this thing? What are we going to call the top bit? The rotor? Let's call it a rotor, for lack of rotor. Lack of anything else. Where are you? Oh, there you are, rotor. I'll turn off the rotor. We didn't put that on the rotor, so we'll call that rotor as well. Get rid of it. It's not really a rotor, it's the antenna. Hang on. Right, let's not make that a rotor. Let's make that, leave that where it was. Okay. Right, so now we've got the thing. Still, that needs to go to the other bit as well. Right, so I need to grab that there and cut it. Oh, hang on, undo, cut. Need the screw as well. Cut, that's better. Paste in place and turn it off. Right, so we can see what's going on. Oh, where's the PCB gone? Encoder PCB, there it is. So we need to make some studs now, 2.8mm studs. So I suppose we could just do it like so 4.4, no, 1.4, 1.4. Right, so we need to lift. It doesn't need to be this wide really, but we'll leave it as it is. So I'll bring that up to there, and that up to there. But now what we're going to do is get rid of this one and this one and push this up. 1.6mm PCB. Let's give it a little bit more. Let's say 1.8. 1.8. So there's your stud, and we don't need to bevel it really. So I put the PCB back on. There we go. We want some little fixings now. Some fixings now. I'll use the nylon fixings, I think. Yeah, let's use the nylon. Keep metal away from this sensor as much as possible. So I'll open up the other one I'd been doing, this antenna switcher, just to get the screw off it. Right, let's get the screw off it. Come on, you can do it. There it is. Right, so we want that screw there. That's it, copy that out of there. Alright, I'll just close that down a bit. Paste. I want to flip it. Let's duplicate that first. Alright, let's duplicate it. And we'll flip this one along the blue. And we've got to grab it by something. Grab it by the center. Stick it on there. And we want another one. Duplicate it. Put another one over there. Now, are they too big? Let's have a look. 6mm, I think they were. 6mm. Let's see if it did make it 6mm. Yeah. So they can just be both pushed down to the surface. That's it. So there's your two nylon retaining screws. Right, and I've got one here that needs to go on the rotor. Because I've put a steel screw there. I don't want any steel near the magnet, so I've changed that. So can I go into that? No, what's going on with it? Oh, that's weird. Right, hang on. Right, hang on. So oh, that is the magnet. Sorry, that is the magnet. Oh, maybe I didn't put a screw in it then. Maybe I didn't actually. I put the brass insert with no screw. Okay, that's fair enough, because then I can do it now. Right, so I'll paste it in place. I'll paste it here. I'll grab it round. Grab it by the top again. The middle of the top. Alright, so we grab it by that. Now we've got to put it over this hole. Maybe like that. And it actually sits indented into this area here, this hex hole. Well, this hole. Yeah. No, I don't know where it goes actually, so let's cut it. Let's get to the top bit here, we'll paste it in place here. Alright, turn it upside down a minute. We don't need X-ray anymore. So this one sits lovely, it's nylon, and it sits flush right inside the hole I made for that. So, which is good because you want it flush so it doesn't interfere with anything. And it's actually in reality a dead fit, so right, so that goes in there, that retains that into the end of the shaft. And then this magnet, the magnet is pushed into this 3D printed plastic that snaps over the end of there, and there's no metal near it, which is good. And also come back the other way around. We've got only metal we've got near this. Well, we haven't actually, we've got nylon screws there, so it's just the chip and there's no metal near it to affect it. Well, the nearest metal will be a shaft pin and nut, so yeah, there is a little bit of metal but it's not right near it. Okay, so we've got that, we've got a little bit of play so the shaft can move up and down without smashing the chip off. Right, okay, so we need to make this now fit onto it, a bolt onto it. So we need some holes again. I'll tell you what, let's just get the holes we've already got, which are on, which bit are they on? Are they on this bit? Oh no. Yeah, they're on this bit, so we get the hole there and there. Right, and we probably need these V bits putting on so that it doesn't get in the way of the belt, so we'll have to grab those as well. Alright, I'll copy them off. Alright, before we get too far, let's make that into a component. Right, have I just grabbed anything else? No, just grabbed that, that's good. So, all that can just be make a component. Turn off the PCB, hang on, let's not select the PCB. So, that's it, all the screws. Yeah, that's good. I'll create a component. Right, we need to give it a layer, so what we're going to call this, PCB holder base. Bottom bottom cover, we'll call it a bottom cover, and PCB mount. There you go. So bottom cover and PCB mount. There you go. Right. I suppose the screws could go with the PCB. Encoder PCB. That's it. Right, encoder PCB there, that's it. Right, anyway. Right, so what we're going to do now is work on this bit and paste in place the stuff I copied earlier. So I should be able to then push that through. Right, so we've got that. The belt needs to go through here, so we'll have to create some slots. Yeah, some slots. So we'll just create some slots, vertical slots. Yeah, they're right. Yeah, they're right. Okay. Oh, actually the belt goes further down. The belt actually goes further down, so... Yeah, we want to put the belt on first and then slot this over the top, so... Let's just say it's... Let's just say 3mm. So we're going to go 3mm down. Let's get rid of these. And push them through. Okay. And it's going to be black as well, because I've got no white left, so we'll make it black. Black ABS. It's better if it's black probably anyway. As soon as I got two brand new full rolls of black ABS, and a bit more like a black box or black. I don't. If I make it black, you can't see nothing, so I make it very light grey. But it'll be printed in black. There's a line there, we don't want that line. Right, okay, so we've got finished. Not finished, but yeah, we've got a lot of plastic just to hold the bracket, but it's not just to hold the bracket, it's to hide the, cover up the, make a cover to fit around a jacket, to fit around the bottom, stop dust and that. The water will still get through, so we'll have to put some drain holes probably around this. Or I'll tell you what we'll do, we'll put a piece of plastic, an angled plastic or a piece of plastic between the two that bolts onto this. No, it doesn't, it bolts over it. We'll have to sort that out. A very thin piece of plastic, 3D printed plastic, to any water that comes through, because this at the minute, yeah, this is actually this is outside. All this is outside. So, well, it was going to be outside, but not now. It's going to have a cover. Got a belt on it. So, anyway, we've got our cover over here sorted for enclosure, top, bottom, stepper cover. There it is. That's in white at the minute, but it needs to be black, so let's paint that black as well. Get it all the same. Yeah, it's all ABS, black ABS, so it's UV resistant and heat resistant up to 90 degrees, so it shouldn't warp. But it'll warp when you're printing it. Unless you really clean that bed. Clean that bed when you're printing it. What we've got here, a bit of a bevel. So we're doing more work there, right? Okay, so this cover clips over the one side. So it looks like we're going to have another cover that clips over, and it won't actually clip over because there'll be a hole in it. Hi, like done. How you doing? Welcome to the live stream. Substain 8915 Substan. Right, welcome to the stream. Let's just welcome them all in. So, welcome to the stream. Yeah, yeah, I'm just doing a cover for the minute for this sensor. It's a mounting and a sensor cover. Well, the belt cover all in one. So when it needs some strength to it, so that's fine. And then probably doesn't need to fill all that in. So we'll look at that again in a bit. And what we're going to do is we'll have to bring this up here and probably go around there. Oh, unless we go, no, actually we can actually go straight over. Let's go straight over, so we need to bring this out, let's say 5mm. Say 5mm out. Right, and that'll allow us to cover the whole thing up, but you still got to, you know, unless you're going to have an oil seal, which you're not, you're always going to get the water in it. So covering it up, just if you've got water's able to get in, and you put a cover on it, all you're doing is trapping the water in. So we'll make it bigger, but we probably won't put a cover there. We'll just cover it in a. If we have a cover around this area, just to stop, I don't know, birds and things. Don't know whether we're gonna. You're an old subscribe on your. Oh, thank you very much. Great week for all humanity. Yeah. Yeah. Oh, thanks for coming in and saying hi. That's good. Yeah, it's not. It's back. I don't know where you are, but we're a bank holiday here in the UK. I don't know if you're in the UK. We're on a bank holiday, so most of the shops are shut today, and Monday as well. Well, maybe not Monday. I don't know. So I've just been in the house today. I haven't done a little bit here and there. So not really doing it. Moon mission. Oh right. They finally get to go. Maybe. I don't know what to believe anymore. You know, I don't know what to believe. I'm from Pakistan. Oh, fair play. I think you've been on before. I remember you've been on before. Yeah. I think you've been on before. Yeah. I don't know. I mean, I don't believe. Look, being a techie. The original missions, I don't think they went, or they didn't go on the first one, definitely. Before they realised it was impossible. They didn't go. The human in the spaceship, once he leaves the planet, if it's even possible, once he goes away, he's going to be frightened to death. You look back and you say, oh my god, anything goes wrong, I'm dead. The sheer fright of that is enough to kill him. Never mind radiation, whatever else. That capsule wasn't capable of taking back off the moon again. I don't care what they say. I mean, yes, the masses would believe it, but if you're a aficionado or anything slight technical, you're not going to either believe it. They've done the calculations. There wasn't enough capacity to lift the oxygen tanks, the batteries, and all that is just not possible. But whether this new one, I heard a radio transmission on the commercial radio. It says they didn't say we're going back to the moon. They said we're gonna go. We finally got a manned mission to the moon or something like that. I thought they didn't say it again or anything because they know. Anyway, that's what. It doesn't matter because as long as the majority believe it, that's all they care about. Unfortunately, the majority, they don't stay away from the pubs long enough to contemplate anything else from happening. Anyway, whether they've been since the initial mission, don't know. Anyway. Yeah, that's my thought on it. Right, so we've got this thing here. So we need to cover the belt. There's nothing else needs to go down here. And the only reason this is so further down is because of this, but we don't need to go. We could bring it across and down like that, but then is there a point in doing it? There seems to be a big lot of plastic just to move that over there. Yeah, so ideal. I mean, it doesn't. If we're just going to have it like that, it could be. And if it's open to the weather, so we need to cover. We need to cover this. Do we need to cover it? Can't leave PCB and wiring exposed to whatever. -4. Oh, okay. UTC from California, right? Nice. So -4. Right, so you go in the other direction. Hawaii? Are you in Hawaii? Or was it further on? I don't know. I should work it out, really. Right, anyway, I don't know, didn't ask you whether you was into ham radio at all. Substain. MS Obtain. Yeah, I don't know what that. Whether YouTube's giving you that name there, I don't know. Anyway, welcome anyway. Right, so I need to. So Yeah, we've got a bit of extra going on here. Oh, that cover's in the way there. So we're gonna have to, yeah, do what we've done over here. Needs to be bolted onto there, so that's right. So bolted all the way through there and down there. And we've got the belt capable to come through to this. So we need to cover this. So I suppose I could just bring that down to there. Yeah. But we don't need it that far down, but it's going to look a bit of a... It's going to look a bit weird with something low level, you know, higher level than lower level. So, and this is a bit of a waste here. So what I might do is cover this up and make it a small piece that sticks out under it. Yeah, because it's not going to get covered up. Oh, morning star means morning star. Subtane, yeah, morning star. That's what it means. Well, welcome, morning star. I don't know if that's your name or your handle. Your handle. That's what they call your nickname or your YouTube handle. Morning star. Yeah. Oh, well done. Right, so I don't like the idea of this thing. Yeah. Right, so I think I'll make. I think it needs to be covered in a small box. So what I'll do, it's got to be fastened from there, and it's got to come down. I don't know how I'm going to do this. So. Yeah, I don't know how I'm going to do this. I haven't quite found out how I'm going to do this bit yet. Now we don't want all this plastic sticking out, so we could do with like... It needs to come down and keep some strength on it, rather than just a little bit that sticks out. So, I'll tell you what we'll do. I'll drop that back. I'll go into this. And we'll bring this back to something, well, let's just measure it. Needs to go to there, then a little bit past, probably. 65mm, that will do. Then I'll push this back to there. Okay, and then we need to go up a little bit. So we'll go in 2.5mm. Draw a line. Draw a line, and let's come up a little bit. Don't know how far. Right. So it's too wide. We know it's too wide. That's okay. So we could basically bring the side in. Something like 45. Let's say 43. So what we'll do, I'll go 43mm in there, 43mm in there, and obviously we're not quite right there. So another 9mm. Yeah. Right, okay. And we want to draw a line. I'm going to draw a line from there to there. From there to there. Okay, and we'll draw a line up. And also one over it. And then we can either draw a line, yeah, keep drawing a line across like that, follow it round. We don't need this one anymore, or that one. Let's draw that down and that one down. Okay, and so bring that down to the surface, and so that one as well, and we can delete that off there, and so we can delete that one, and we don't want that, so get rid of that and that. Okay, and we've got a bit of a weirdness going on here, but anyway, we need a box around it. And I think we'll bring the box all the way up to the top. Right, so I'll put a box around it. Okay. So we can bring the cable up and in and through. So we're still out of the way of the. Yeah, we're out of the way. We've got some strength going on here. According to astronomy, a morning star is a Venus planet, not star. Okay. So it's being lit up by the sun, which is a star. Yeah. Yeah, old Venus. So some people don't believe there's anything out there. I think the star is just some part of the dome or something, or the sky. They don't believe there's anything out there. So you got different ideas. A lot of people, different ideas, and you can't tell what to believe anymore. Nobody can really tell. Right, I think I've drawn that, and I'm not actually on the model, so I'll have to grab those two, cut them and put them in the model. Now they're there. Right, that's better. And we might as well bring these up to match the height of these, and take away this line. Okay, and that one. So we've made a little bit of a box that looks like a trap for water to me, but right, let's just have a look back off it a minute. So the cable's got to come up here, and it's either got to come up here and into there. I suppose we'll just lower one of these a bit. Come down, I don't know, 10 mil. 10 mil should be enough. So you can run your cables up there. Now we need the PCB in place, and the cover of the plastic needs to be just above the screws. So I could just go into this. Actually, I need to know where the screw is. So I need the top of the screw. Oh, did I cut that? I need to copy it. I'll tell you what. Copy, not cut. Right, go into here and paste it in place. That tells me the height of this. So first I want to do is reduce this down to the height of this. So I know where to start, and it needs to go up to 2.5 millimeters. Right, so then I can come down 2.5. 2.5. So first you design it around what is necessary, where it needs to be. Then you sit back and look at it and think, does it make sense? And if it does make sense, let's get rid of that now. So I'll just and of course you've got to get your PCB in there. There's another story. So you can't cover it up. You want it covered, but you've got to get your PCB in there. So this is going to have to be an extra piece that fits on by the looks of it. Yeah, it's going to have to be an extra piece that fits on. Venus is the brightest object in the sky. Okay. You might be right. I don't know. I don't know. Venus gets ignored a lot. Venus. They tell us it's too hot. It'll never be able to do anything on there. Too windy and too hot. So whether that's just to keep people away from it, I don't know. Anyway, so let's fill this up. So if I go across here to there and there to there, right, so we've got that there. I need to take off that, and that. Have a look in X-ray mode. Right, need to get rid of a few bits of, yeah, it's too hot. Right, what's that like? It's okay, but it's, yeah. Right, so we need that to be a separate thing that sits on. So we'll have to bring back that. Right, so this is now going to be something that clips over. Yeah, it clips over it. And it needs to be thin as well, the top bit, because we've got to get the magnet to come through to the chip. And I've already got the screw height there, making a gap. We don't want too much. So let's bring this down. Say let's bring it down 1 mil, so it's 1.5 mil thick. The sides can stay the same. So we'll need it to be something that you can push on, clip on. Right, so I need to grab what I've done now, copy it off, copy it, paste it in place, and then make it into a component, and go back to the original and get rid of it. Get rid of the original, which is done by dismantling it, dismantling the parts we don't want. Okay. We don't need that, or oh, we do need that at the minute. Let's put that there. Okay. Right, so we don't need... Do we need slots? I think we need some slots in it. So we can push the lid on. Or maybe it needs to be slotted on. Let's just get rid of it. We'll work out how we're going to get it to stick on in a minute. Right, let's just get rid of the bottom. So we're back to something. That's okay. So now if we come out, we've got this bit here we need to sort out now. Oh, yeah, we seem to have copied too much stuff. So I need to get rid of some stuff. Just get rid of that out of there. Oops. Okay, back around the other way. So this is a little lid that goes over it that allows for the wire we don't need this bit. Alright, so we've got that. We're missing a bit of something here. Alright. What's that looking like? Is there something in the way? Yeah, we've got an extra bit of geometry there. Yeah. Oh, no, that's the wall. So we do need that. Oh no, we don't need that. That can come away. Right, okay. Anything else that needs to... No, I think that's everything. Obviously there's no way... Is there a lid on that? Has that got a lid? Yeah. Right, so we've got that. So that can go back with the rest. Now it's got to be fastened somehow. So I don't want it to be sealed, just want it to be a dust cover. The wiring needs to come up and across. So that needs to be 3D printed upside down, so it makes sense to bring the wire up here. So I'll need a... Let's just say we need that one to come through to here. So we'll grab that, copy that and paste it in place, push it through. Okay, what's that like? That looks weird. Okay, it looks weird, but it's right. Okay, so we don't need this anymore. So we've got enough to get the cable through into this other chamber. So we've got yeah. Now what holds this in place? There's nothing to hold that in place at the minute. You've got to be able to get to it to screw it in place, so we'll have to sort that out. Let's come out of X-ray mode. Let's just save that so far. Right, I'm going for a little interim, which means a toilet break. A toilet break. Oops, got no colour. And we've got the colour. Right. Oh, got no colour there. Let's get the colours right. Colours right? No, almost. So we've got to somehow be able to fasten that to the plate. Fasten it to there. So how we do that? So we put the sensor in, put the cable out, and the cover goes on. So whether we have lugs here that stick through to locate it, we'll have to sort that out in a minute. I'll be back in a few minutes. Right, I'm back. Do you know about 20-meter band hex beam antenna? Mono band. I've tried to make. I've designed stuff before, multi-band. 20-meter band hex beam. Yeah, I made a hex cobweb. Designed a hex cobweb once, and I got all the bits to make one, but never installed it. But I would. Why don't you try a Moxon? And use that as a beam, a Moxon antenna. It's easy to build than a hex beam. Yeah, try a Moxon. I'm gonna put a Moxon on this one. Even though I've just built, put that little representation, but you bolt on what you want, see, a Moxon. Yeah, so no, there's so many antennas. So many antennas. Vertical Hustler, the one I've got, Hustler 5 BTV. So yeah, but I'm not using that at the minute. I'm using, what am I using? A HF 360 fiberglass. Rubbish on 80. Not so good on 40. It's pretty good on 20 meters. But I think you need to switch between a long wire, horizontal, and a vertical. You need to have the option different times of the day, I think. Yeah, I'm going to put a Moxon on this one, even though I've just built, put that little representation, but you bolt on what you want, see, a Moxon. Yeah, so no, I think So yeah, different times of the day you could do with different ones. Yeah, I mean this thing I made here. Where is it? This thing I made, I haven't deployed it yet. Made this thing. This was going to be a fan dipole with 3/8 whips on that says driven plate like a DX Commander, and then you got a ground plate with whips on. But the idea with this was supposed to be able to I'd have it that way up like that, have it that way up, and then you can rotate it so your whips are sticking out here, either side. Then you rotate it, or you can have it that way up and rotate the angle a bit like that. Well, that was that one. It's got a 1-to-1 balun on it. But I bought some whips, but I haven't bothered to build it yet because there's no way. Once you put the whips on, there's no room in here. It's a pity the frequency that everyone uses is long whips. If it was 77s or smaller whips, you could model them and do all sorts with them. Probably get burnt off them though. You get burnt off them probably if they're putting some stuff through. And I got this hex cobweb I was building. Yeah, this is going to be my hex cobweb. This is a centre bit, like a hex beam. Your coax comes in here, and you go in your garden and you attach guide wires. Some of them have got their guide wires, yeah, that go out. And I made a load of these. on the CNC. This locking system. So basically, what you do is you have your guide wire, and you lock it in position like this, and then it stays there locked, and it holds. You run your cobweb antenna through it. So to swire it in, you undo it, you move it across. You can lengthen, just tune it between the bands. There's some insulators I made. So anyway, that was 2 years ago, I think. Still haven't done it. My excuse was that I was waiting for the weather to get better. Dipole delta antenna is easy to make, I think. Yeah. Some people have two. They have two like that, co-phased or whatever. I tried two Ampro 40s and 20s on a delta, and I couldn't tune them. They wouldn't tune. But I didn't want to cut the whips, so maybe worth trying again. But I think I'm going to do a Moxon. I'm going to have a Moxon, I think, because it's just the way it's made. It seems a bit simpler. Yeah, anyway. The antenna is the biggest problem. You got your radio. Your radio is useless without your antenna, You can have all the expensive radios you want, but unless you've got a good aerial, you're wasting your time. Good antenna. Difficult. That's the trick. That's what the hobby is, I think. The antenna. Creating the antenna. Ideally, the way I see it, you want an antenna length and angles that can be moved via CNC or from remote, so you could self-tune it. When you say tune it, I mean bring it into resonance. So you can look at the signal. You'll need a stationary signal. It's difficult on HF. It's up and down all over the place. But you need to alter it to whatever you want to do. I don't know. Or find the ideal. When you stay rigid, when you just fix it up and it's rigid in place, you're fixed. Who's to know if you increase the length of one element or decrease it or put a little capacitor on it? Who's to know that that little bit of extra won't make all the difference? But when you're fixed in place, you can't go out and touch it, because the fact that you're there will throw everything out. So it's very difficult. It is difficult, and that might be. Is that money? Yeah, that's money. Money! Right. Anyway, let's sort this out. So we're gonna. This box is gonna clip over this box. Ideally, it'll be pushed in place without any fixings. And gravity will take it. So what I'm going to do is I'll put some lugs. Yeah, so we've got a hole cut out there. X-beams are very hard. Yeah, there's a lot of pieces. It takes a long time to build it and very expensive, unless you make your own out of 3D print. Yeah, but it looks. I mean, ideally, how are you going to hide your X-beam? You can't hide it. You can't hide it. Yeah, it's difficult. I don't know. It's a weird one. That's almost touching that. Look at that. That's actually touching that. So we're going to have to rethink that a little bit there. But we'll sort that out in a minute. So what I was thinking on this, if I make some lugs. Right, if I... Yeah, actually. If I... It could do with going through it, so the water doesn't go in it. The water will have to go round it. So let's have a look at that. So if I push it in there, yeah, let's do that. Let's increase the size of this by 2.5 mil. Right, that'll come through. Then we've got to increase the size of this by 2.5 mil and this by 2.5 mil and the lid by 2.5 mil. So we can push that in. Oh, no, it wasn't 2.5, the lid, was it? I brought it back down by 1 millimeter. That's better. Right, so we've got that. It pushes in to there. So it just pushes in. That holds it in place there. Actually, this overlap will hold it there, but we need a lug. We need a lug, I think, in there just to clip it in. The problem is you haven't got space to clip it in. So really, it pushing in there is better for us. Now, how can, yeah, so you go that far in. The back sits against there, but what guides it in here? So when we print this bit out, we could do with 2 guides, really. Yeah, some guides. Okay, let's make a guide then. So we want, yeah, so if I put some guides like this and just bring it out 2.5 mil, 2.5 mil, put a thing And how far do we need to go up? Do we need to go a lot? Not a lot. It's just a guide, isn't it? 2.5 mil. 2.5 mil. Oh, that's the wrong one. I might as well paint that while we're here. Right, so we've got a guide. So we can slide this cover on from the side. And as soon as it hits the ear, it'll stop. So what keeps it clipped in? It could do with snapping in place instead of sliding back off again. So something here, clip wise. Yeah, I need something here just to clip in, like a notch. A bendy bit and a notch, but again, it's getting too complicated now. Anyway, so we can work that out. So we can withdraw that, fasten. So you'd have to fasten it to the bracket first, the PCB, with the cable coming out here. Then you'd push this over the top. And that'd be like a weather shield, sort of. And because it goes inside, the rain's got to come in and round. Right, okay. And I suppose we could build a small wedge shape here. No, don't want to go too crazy. Let's keep it simple. Right, so this has got to be altered here. We don't need all this now. As soon as we've got this here, we don't need all this. So in that case, I suppose we could just as well. We need the sides if we're going to cover it. I don't know what we need. No idea what we need and what we don't need. I'm making it up as I go along. Could develop into anything, this could. Could develop into anything. Right. So that's quite. No, that's actually almost touching it. Almost. I think I need some X-ray to have a look what's going on. See where the spacing is. So you've got your studs. I could always bring it down a bit. So yeah, you got your. So what we need. What we need is to lose a bit of this 1.5 mil plastic. To lose the screw heads at least, so we can, yeah. Maybe. Yeah, let's do that. It's going to be a tight fit. So, bottom cover. No. So, haven't we give this one a name yet? No, we haven't. PCB cover. PCB cover. Alright, so turn the PCB cover off a minute. Right, PCB cover off. So we want to get the screw holes. We need something, so what do we need? Let's just take these two here, copy them, and bring that one back and paste them in place. Turn it over, lose the 3D X-ray, sorry, X-ray, lose it through X-ray, and oh no, I didn't want that. Get these back again, these back again. Not going too well today. Right, they need to move down to the floor. That's it. So that'll do. I'll just hollow them out. How far do we go? Not a lot. 0.75. Okay, so we've got a couple of holes that will help us lose 0.75. Yeah, 0.75. Let's have a look at it now. Yeah, so, oh, we haven't lost anything, but we've got to shorten it down, move it. Yeah, we need some clearance, so we've got to now move that whole thing down 0.75. Let's do that now. Down 0.75, and I'm gonna have to move this whole thing down 0.75, and that should be all good again. We've got enough gap. Now the chip is still too far away, I think. I've had an idea. This is a brilliant idea. Sort of. No, it isn't. It isn't a brilliant idea, is it? No, it isn't. No, it's not. I'm thinking of attaching it to the lid, but these spaces are going to be too tall away from here. No. So I need countersunk screws then. That's what we need. Countersunk screws. Let's just see how many millimeter it is from the chip to 3.2. It's probably alright. It's less than 5. It's 5 mil away. 5 mil away from the magnet. Yeah, I think it'll work. Right, I think that's going to work. Should be able to do 5 mil. Right, so we've got these guides, so we slide it on in there, and it keeps it in. How does it keep it in? How does it stay in? There's no real way of staying in at the minute. I'll tell you what. Yeah, if we have two little lugs here. So you can't slide it in on an angle because you haven't got your gap. No, it's got to be slid in where it is. I think it'll stay where it is anyway. It'll be a tight fit anyway, won't it? There's nobody going to be pecking at it. No bird's going to be pecking at it and trying to make it come out, I don't think. Right, let's just have a look at this. Right, so we don't need that anymore, or that. Right, everything else is good, yeah. Yeah, we don't need to do anything else with that. Okay. Right, okay, that can be printed then. Yeah, that can be printed. That's quite a big gap just for the cable though, isn't it? Do we need that much of a gap? Probably don't need that much of a gap, because the lid's going to be printed. Yeah, so we could make it smaller. Just enough for the cable to come out. So if we make it tell you what, let's do it. Let's go back into this and seal that. Now, do we want to seal it though? Right, so if I draw 2.5 mil there, 2.5 mil there, and draw a line. Okay, and if I pull that out to the middle, where's the middle? There. Oh, why has it got a funny step on it? Oh, it hasn't, that's right. And then bring it back. We need to bring it back enough for the cable only. So bring it back. I don't know how far. 5 mil. And then do the same with this one. And bring it back 5 mil. Right, so we've got that bit of a, yeah, that'll do. And we need to make it come out. So now we need to 2.5 mil this way, 2.5 mil that way. We draw a line. That's it. And we've got to pull this out 2.5 mil. Right, so yeah, we've got sort of that going on now. What have we got going on? Something like that. Right, so we've got the roof still. Oh, we're coming out through it. Yeah, that's good. And we're going to push that through the hole. Just enough for the cable. Are we too thick? No, we're not too thick. We're okay. Yeah, looks good. Right, so then we've got to... that pushes into there and butts up against this. And... we're too long now. Yeah, so what we're going to do is reduce this whole lot by 2.5 mil. And then bring the sides in. Bring those into here. Oh, it won't let me bring them in, why not? What's stopping me? Oh, the guides. Oh, the guides are in the way now, aren't they? Are they? No? Right. It's not letting me do it. Right, let's find out why. Why, what? Oh, it's brought them out as well. We don't want that, do we? That was why it wouldn't let me do it. So undo, push, undo, push. I just need to add these lines here. Back. Put the lines back. Right, so then I can push them back independently. Okay, so view the rest of the model. I should be able to just push that back to there. And this one back to there, like that. And everything else stays the same, I think, yeah. Let's have a look. So we've got that bit there that pushes through there. Right, we've got a bit of a line there. Why have we got that line? That line shouldn't be there. Oh, I don't know what that line is. Oh, well, it's something we don't need. Let's get rid of it. Right, so we've got rid of the line. That's good. So far, so good. And let's just make sure this is okay. Yeah, I think that's okay. There's nothing weird about that. No, we're alright. And that can be printed upside down like that on the bed. And it's able to do all this extra height and lowering. Yeah, so that'll come out okay. Rightio. Right, so okay, we got that bracket. Well, that's all we need for now. This bracket allows the belt to go through. We can mount the belt first and then push this over and fasten it through to hold it still. And put the lid on, and the cable can come out here, and it's got to get up to the control panel, which is, hang on, let's get rid of the enclosure lid. Top, where's the lid? Stepper cover. Yeah, so it plugs in over here. Plugs into the I²C there. We haven't got a hole in this yet, so we're going to have to drill a hole in this. Is there a way through? There's not a way through, is there? So we're going to need a way through from there into there. So I suppose we'll just go straight up here. Put a hole in. It needs to be big enough for it to pass it through a 4-pin DuPont connector. So we need a small amount of space in it, yeah. And yeah, so what we'll do is we'll just go, is that halfway? I'll keep it in line with this, I think, like that. Right, then we'll come up away from the edge, say 10, no, let's say 8 mil. Let's say we want to do 10 mil. And we want to come this way 5 mil, let's say 5 mil and 5 mil. And we'll just chisel out a 10 mil square bit. That's it. So on the one we've printed so far for the prototype, we'll just drill a hole in it. But when we make another one, we'll have a hole in it already. Right. So the cable comes out of here, goes up here, and then plugs into there from there. That's it. This cable goes straight into stepper motor board, and there's a ribbon from this that goes into the SPI or the Lalin display, and that's that. Right. Okay, we'll need another glandole to come out with a stepper motor cable exit point to go to antenna switch. So this will also switch the antenna as well as stepper motor, the antenna switch, and this one. 2 stepper motor outputs, so we've got that there. And that'll just guide itself between the guides, won't it? And it'll stop coming up because it's poking through here. I suppose what stops this lifting? You could have an underhang here, couldn't you? Yeah, we could, because we're going to print it upside down, so we could have a little bit of a... yeah, we could have a little bit of an underhang. It won't hurt, I suppose, to have an underhang. That stops it moving. Let's just try that, actually. Let's try it. Let's just go up another 2.5 mil. And then just draw a line 2.5 mil, and let's just do something weird like this. We're not actually in the model, so we'll have to cut that, paste it in place. Oh, where's it gone? Hang on, undo paste. That's it, paste it in place here. Right, so we'll just slot it in. Oh, can't get to it. Can't. Oh, I see. I see. We can't do that because we're on a weird bit of an angle. I don't think we need to do that, as long as it holds it in. Let's just see what it looks like. So we come in there just to match that. We don't need that, do we? So all we need to do is come down from there. Just come straight down like that. Is that right? Yeah. And get rid of that, that and that. Just put that there, and same over here, like that, and get rid of this and that, and fill that in there, and we want to fill that in there. That's it. We got to get rid of this line and this line over here. The trouble is it's got to print an overhang, but we don't want much of an overhang. We don't want that much, so we'll reduce that. Just wants to be a bit. Oh no, it's going to slide on, but how do we print an overhang? So we've got to work out how we're going to print the overhang, because it doesn't like to print upside down. I think a CNC machine makes matrix into real life, like customize anything. Am I right? CNC, yeah. If you get a standard CNC for metalwork, you can get more accesses. You're looking at loads of money to be able to mill underneath. So with this idea, we do it a slightly different way. with 3D printing, you can get away with a certain amount as long as you do it in a certain way. So what I'll do, I don't want a fine point. We want a fine point, but not much. Yeah, so what I can do is I'll just grab this and move it in. That's 1 mil. So it's sticking out a little bit. So it should be able to cope with a little bit sticking out. Should be able to. Yeah, you can, because it prints it quick and it goes off quick, and it's already sticking to something else that's nearby. It does manage to print it. If you go out too far, it's cantilevered and it just string starts to develop as it's printing. The gravity, ideally you want to do it in 0 gravity really. Well, that'll be no good either because it won't stick to the bed then, or you know, it'll just be floating all over the place, so you can't really win. That'll do. Okay, we'll try it, and if it's too much, we'll reduce it a bit more. Okay, to get that to slot in, ideally what we want is a bit of a 0.5, yeah. To get that to slot in, we don't need nothing there, or there, or there. But that bit, we just need to take that down to there, that down to there, and then we can grab this, move it in. Move it in. No, it's not doing it, is it not? What's it doing? I don't think it knows what I was trying to do. Hang on. If I push that, if I can get the angle, which angle is it? That's it. 0.5. There we go. So I've made a bit of a bevel edge, so it's just easier to slot in. Yeah, so slot in. Does it need to have a slot there? No. Now we'll leave that like that, and the rest will be okay as it is, I think. Yeah, so we'll be alright with that. So we've got the slot that just slots straight in there. Yeah, that will work. Right, okay. So we don't need this anymore. So when that pushes in, that little clip will just stop this rising up for whatever reason, wind or whatever. I don't know. It's probably not necessarily, but anyway. Okay. Do we need a little mark on this so we can see if we're centered up, or we can probably see it anyway. So you could put north, east, south, west, but you don't know which way you're going to put your bracket, so that'll have to be custom. Right, so you've got that bracket there, and we've got the cover, and we've got the mount for the PCB. What we haven't got is a cover for this yet. This is the cover, so we want the drive belt will be showing, and the drive belt will be showing here. So we want something to cover this wire up, so I'll need something to go on here. Now, do we make it all part of this? Yeah, I think we should make this in one. So it's going to have to cover all of this. Now the problem is we've got to put a fixing through there and screw this together. And how can you do that if the cover is stopping you getting to the screw? Yeah. So you got to make sure you can make it. See. That bolts through there. And we want the cover to go, unless we have another slide on cover. Yeah, we'll have to have another slide on cover. That same idea here. Okay, now is there anything we can print in the meantime? Can we start that printing? Not yet, no. We don't need to print yet. We could print that, but there's no point. No point in printing that, although, because if we wanted to change it, I don't think I'm going to change that, so I think we'll print that off now. Let's get this ready to print. As soon as I've got the printer on already. That's not going to change, this bit isn't. I have to sleep now, I don't blame you. It's probably late, isn't it, where you are? Yeah, okay, well, 7.3, we'll say MS, we'll say 7.3, have a good day, or evening. Yeah, thank you mate, thank you for joining in the stream. You're very welcome, and I'll see you again next time maybe. Have a good day. Bye for now. Right, so I'm about to save this. What am I going to call this cover? Oh, we got some stuff. Control panel enclosure. No problem. You have a good day. See you soon. Right. Antenna rotator, enclosure, stepper spacer, lid, chassis, base. So it's part of the base. So this one's going to be called the encoder cover. Encoder slide on cover. Right, that'll do. Okay, let's get this on the go. Slide this over here. Right, where are we going to put that? Have we got room for it there? Yeah. We'll just make a new plate. I haven't even numbered these yet. I should have numbered them as I went really, but because I'll never number them, will I? I might do. Right, so we're going to import this one here. If I can find it. Slide on cover, there it is. Right, let's just make it the right way up. Do we want it that way? I don't like to print stuff that way. I don't know why. We'll do it that way though for this. We'll do it that way, and it needs to be in black. So I'll do it in this black, but there's not much left in that roll. But I've got the same stuff in that one. I'm trying to use up some scraps. So it'll just say it's run out, and I'll just tell it to. Maybe it'll go and use the other one. Maybe. So let's have a look at it. Looks okay. Brim. Let's slice it up, see what happens. Let's put a brim on it. That's fair enough. Right. Is it going to be able to do the over? It's not reported any errors of overhang, so it should be alright. Let's do it. 28 minutes total. 20 pence. 20 pence. Yeah, that should be alright. It's only a little cover. I could have probably made it thinner, but yeah, it doesn't matter. Alright, yeah, so I've got two nearly empty rolls in these two slots. Let's see, let's just watch this going on. And 8 o'clock. How long have we been going? 2 hours. Yeah, probably end it there, I think. Yeah, I'll probably end it there. Let's just have a look. So let that carry on a minute. So what have we done? We've made the bracket. So we need some way of fastening the lid to this bit. So it needs to be a lid, or at least the holes for the lid. So it's going to be something like this. A push-on cover that fastens to the outside like that. That just covers this up, and it would have to cover all the way up to the top. So we could quickly draw something up, I suppose. Yeah, let's draw something up. So, tell you what, let's just draw something up. Draw something up to there, and we'll come across here to there. Across to there. Right, something's gone wrong because it hasn't drawn it. Yeah, it hasn't drawn it, look, because it's not level with anything. Right. Right, so something's not level. I think it was that one. Okay. Right, we've got a cover. So that's the framework for a cover. Now, that's part of the chassis. There's your base. So this cover, it just wants to be, it's a dust cover really, or it's not going to be waterproof, it's just a cover. It needs to sit inside here probably, although it look a bit weird looking. Okay, let's give it 2.5 mil. 2.5 mil. Now the front needs to have some sides. Is it going to just push in over here and be smaller than this? You've got your cover going on. Where's your cover? Stepper cover. So put that on there. The cover's the last thing to go on. So, and it's already, we have got to make another one of these though. That'll be the third one I've made. If I make another one, well, it's got to have a hole in it anyway, hasn't it? So I could bring that back enough for this cover to sit on, but then the cover would want to fasten over top of the lower cover, so you got to put the lower cover on first, then the upper cover. Or I like the idea of being able to remove any cover without having to take another cover off first. So how do we do that? A clip-on cover. I don't know. Problem. Anyway, we'll think on it. We'll leave it at that for now. That's enough for a Friday night, isn't it? On the stream last night I thought it was Friday. I actually said it was Friday. I realised after it was Thursday. Anyway, let's leave that. So I could just print that off for now, but I've got no way to attach to it. So I could do with some lugs. Tell you what I'll do. How do I attach to that? So I need something to push through. Yeah, some square lugs that we can just push through. Yeah, I like the idea of that. So let's do a few lugs. Let's go into it here. Let's go over, I don't know, 2.5 mil. 2.5 mil. Let's come up 2.5 mil, and let's make the lug I don't know, 5 mil tall, and it needs to be in 2.5 mil. 2.5 mil, and we'll probably need another one at the top to hold the side in. So if we keep the same idea, 2.5 mil and 5 mil, that's it. So we've got some holes to push out, which we're going to use as locating lugs. Yeah, use them as locating lugs. We're just going to push them through. Just so we can get this bit printed as well. Right, so we've got the sides located. Now, is there... Oh, Andy. How you doing, Andy? I was just about to go off in a minute, yeah. Let's say hi to Andy. Yeah, doing alright. Yeah, I'm doing alright. I'm just doing some more work on it. Sorted out the magnet side of it, this bit here. And that pushes on nicely now with no problem. And then we've got... you can't see it. Hang on, where's the PCB? PCB. Oh, it's on there, it's just it's not in the right section anymore. So if I move that cover, yeah, so we've got the magnet, we've got the PCB held right where we want it, we've got a slide on cover that slides in here so the cable could come out here. We've made a hole in the top so the cable can go up. We're just doing a bit of a push on cover for the bottom. I want to print this bit out as well. So we need some lugs in it. Actually, those lugs are too low. So good job we spotted that. So we need to measure from there to there. That's 10 mil. So we need to bring these lugs, these two lugs, lug holes up 12.5 mil on this one. 12.5 mil up. They might be too high now. Let's have a look. Yeah, they're too high now. That's it. Hang on. That one's just right there. Yeah. Now this one. Right. Okay, hang on. So we've got that. 15 mil, so it just needs to come down 2.5 mil, I think. So drop them back down 2.5 mil, and this one drop that down 2.5 mil. That's it, and hopefully they'll be about right. So they're sticking off this, and actually no, they could have gone flush, couldn't they? Oh no, because you've got the thickness of the cover. Oh, there is no thickness, there's only sides, so yeah. Right, so they could just go back down to that. Let's do that then. Almost there. Let's just have a quick look what's going on with this. So it started printing it. Yeah, it might run out of filament because I've got 2 rolls of black. I'm trying to use the filament up. There's not much left. I've got 2 full rolls. I'm trying to get rid of these. If it runs out, it'll come up with a little thing, and I hopefully can tell it to use the other one there. Right, so I need to drop that down by 2.5 mil, and also this one here. It's looking good, yeah, it's looking good. Oh dear. 2.5 mil. I don't know if it's looking good or not, because I'm adding bits to it, and it's a bit of a concoction, Heath Robinson, but as long as I can make it look okay and feel okay. So I need a push-on lid. So you've got this push-on cover for that. This is exposed to the elements because we've got wires in here, and we want a push-on cover for this, so the wire can come into, from there down into there where the control panel is, and we need to push this on and clip it in. But what's going to hold it in? What's going to need some way to clip in? Probably some lugs that push into here. I've got to make another one of these again because I've got that hole in it, so I could put the lugs in there, but I'm not going to build this bit yet, this cover just yet. I'm just going to end it. I'm just going to fasten this to this and get this encoder on. This cover is an afterthought, so yeah, so at the minute I'm just going to drill a hole in the existing one to get the cable through, and I'll make this up on the next stream. But what I wanted was the lug holes in place here, so I could print this out, and yeah, so I could print this out, and this holds the PCB as well, and the guides for the runner, the cover. You drop your PCB on there, you screw that in. Right, okay, I think so. I can then print that out, you see. Yeah, I can print that out like that flat, and should be able to cope with. I'll have to put some support there. Doesn't need support there because it's going up. These will be alright, but if I got support on anyway, if it needs to, it'll just fill them up. Right, the begs the question, do I need this? It's acting as a strut. I could hollow it out, couldn't I? Let's have a look, because it's got a rain on it. And this needs a support, but it doesn't need to be solid plastic. So, do I hollow it out, or do I leave it? That needs to be where it is. I'll just leave it, I think. Or I could hollow it out. I'll tell you what I'll do. I'll leave it it's going to be printed that way up, so I'll tell you what, I'll put some indents in it. Oh no, can't do that because it'll pool water. No, we'll leave it. Knock them through all together. Yeah, let's knock them through all together. Right, let's save a bit of plastic. Let's just go here like that. Come in. I don't know how far to come in. Let's just say 5mm. 5mm. We'll knock that through there, and we'll do another one. 5mm, and we'll knock that through there. That's it. So we've got some strut to stop it wobbling and stuff. We can print it flat, and we've saved a bit of plastic as well. Yeah. Okay. Right. Then that begs the question: do you need all this? Yeah. We need all that because we're trying to cover it up, aren't we? We don't want little robins to nest in it and stuff like that. There's something, yeah, something not quite right with the cover here, isn't there? That's the problem. Yeah, I haven't printed the cover yet, so what I need to do is measure that 2.5mm and 10mm, so I need to just make a little cut out there. I need to go up like that, 10mm, and draw a line like that, and push that back to there. Get rid of that, and hopefully that will just sit on that corner like that. Yeah, that's okay. Right, that'll do there. What about the other side? The other side is okay as it is. Right, okay. Yeah. Yeah, because we want the water to drip down here. We're not gonna cover it. The worst thing you can do is cover it, because you can't stop the water getting down this shaft and leaking down here. So don't try to stop it. You need to cover your electronics up. So you got to cover that. Gravity's your friend, so we've got to work out some glands to cable to this as well. Ideally, so in that case, we need to somewhere some cable needs to come in here, up from the bottom. So this cover will have to have some slots in it, and the new base will have to have some holes in it for the cables to come in. Yeah, so that's another reason to leave that alone for a bit. But as long as we can print this bit and this bit, actually that bit, no, it's doing well for a little bit of cable that was left, little bit of stuff that was left in here. I think it'll run out, but you never know. Right, so anyway, right, so that's okay. Yeah, that'll do. We could put a strut this way. That's an idea. Could put some strut that way. It's printing it face down, so you could put a strut. Does it need a strut, or is it okay? It's only, probably doesn't need a strut. I'll leave it as it is for now. It'll probably be fine. Although it could get heavy, couldn't it? So I'll tell you what I'll do. Let's put a bit of a strut on. Not much, just enough. How far do we need to go? So this could be brought up So the easiest way to do a strut here is just to actually grab that there, grab that and move it up, and just level with that. Okay, can we do the same again? Let's see if we can do the same again. Right, have we distorted it too much now? We've got a bit of a strut now. We've got a slight bevel, that's okay, because it'll water rain off it a bit. In fact, we could take advantage of that. Could drop that corner down a bit. No, let's leave it. Let's leave it like that. Yeah, they're both the same, so we'll leave it like that. Let's give us a little bit of a strut. Yeah, a bit of a strut to give it some strength. Better than nothing. Instead of just having a thin 2.5 mil, it's got that as well. Right, it's still going, is it? How's that managing to go? There was hardly any filament left on that reel. Clever. Right, okay, so we've got that. Okay, now what we need is to make sure there's no non-manifold edges. So I need to look at it in 3D, see if there's any non-manifold edges stuck in it. Can't see any. Yeah, I can't see none. I think we're alright for non-manifold edges. Let's have a look over it. Yeah, I think we're alright. Okay. Right, we'll go for that. So it's only fastened there and there. Yeah, so it's going to be quite rigid there. That's okay. Yeah, should be alright. It's going to flex a bit, but it's only very lightweight PCB. There's nothing to it. Right, okay. So, trouble is now I need to move these pins out of here. They're actually in the model. Hang on. So I need to go into here. I need to grab that and that. Cut them out. Cut them out and paste them in place. And it needs to be. I'll leave them there for a bit. Smooth this. Export it. And this bit is the next bit to print. So we've got the cover, lid, slide on cover. So this one is going to be the encoder bracket. Encoder PCB mount bracket. Encoder PC mount bracket, that's it. Right, okay. So yeah, does it look like weird? We've got to sort out another day. Sort out this back cover, which I don't need at the minute. Yet. I don't need it yet. But I just need to. I've got the holes to snap into it. We'll need to sort out this, fix into there somehow. We'll sort that out. Have a little push on and clip in thing. Right. Okay, so we don't care about the water coming through here. It can't go onto the PCB. Actually, I've just had a thought now. Just had a thought. Wouldn't that be better if it was over this side, so the water can't go in? It might have been. Is there any room for it? Not quite. No, we'll leave it like that because we want the struts. Maybe on the next one. It's the PCB is raised anyway. It's raised anyway, and there's water output here. I should have put some drain holes really. Oh, I haven't done that bit yet anyway. Right, let's do that now. Luckily I haven't printed this out yet. Put a couple of drain holes in it just in case the water seeps down the edges. Right, let's do some drain holes. Let's do one at 10mm this way, and we'll go halfway. 15mm that way. 10mm, 5mm this way, and 5mm that way. Let's put a few drain holes in it. Make the drain holes, I don't know, 1.5, so 3mm. Right, okay. Just need to push them through. Some drain holes. You can't get rid of water. You can seal it temporary with all sorts of silicon, but after a few years they'll perish, and all that happens is, oh, what's happened there? Look at that. That's what happens if you get too lazy to manoeuvre the drawing round. Try and push through something that's not there. Right, let's get rid of these. So yeah, I'll get this on the go anyway. Might as well get this on the go, this printing. Is that in the middle? It's not quite in the middle there. Doesn't matter. It does matter because it's bugging me already. It's bugging me. That'll do. Right, so we've got some drain holes, and they're the PCB's mounted up, so that's fine. Unless gravity changes all of a sudden, it'll be good. Right, okay, that's that bit done. I need to go and do that again then. Export that one all over again, and PCB mount bracket, that's the one. Right, okay. Let's have a look. What's going on? Has it run out? No, it's finished it. Fair play. So I can then run up get the other one on. Let's bring in the new one. Bring in the new one. Find it. Encoder PCB mount bracket, there it is. Right, so we're the right way up, but we're over top of that one, so we need to say not printable for the other one. Right, we've got to do some clever bit of printing here that holds that down. I think I'll print it, rotate it around so I can see what's going on. Let's say 180. Right, so that'll print. The camera's in this corner. Yeah. Okay, that'll do. And it tends not to print. It tends to lift the corners up. Don't know why. It's like the ether element. It gets thinner towards the ends. So what I'm going to do is I'm going to rotate it back. So 45 degrees. That'll do. I'll print it like that. Print it like that. Yeah, can I see what's going on? Not really, no. Okay, so I'll move it again. 180. I can see it now, what's going on, and I'll bring it forward a bit. Take it across. That's it. There's that. Maybe that way. Yeah, that's it. I can see what's going on with it then. Right, that's it. So let's slice, save the project and slice it up. Right, so we've got 1 hour 9 minutes. Just enough to print before I go to bed. Let's just have a look. It's in black, so it's a bit weird looking. I think it's okay. Oh, does it need cantilever support? Didn't say anything about cantilever, did it? I think I'm going to give it some support. Right, let's slice again. Yeah, let's put a bit of support there. That's good. Put a bit of support to hold that overhang, and I think that's about it. That's all it needed. It didn't put any in the holes. It didn't need it, so it's just that. That's fine. Right, so we can print that. I've got to go and take the thing off the bed. Anyway, I think that's going to be it for tonight. 2.5 hours, that's enough. So we'll just have a look at the thumbnail, make sure we covered. We certainly did cover the thumbnail. Okay. Anyway, that's going to be it for tonight. I'll give you a quick overview. Quick look at this before we go. So we've got a bracket. We've fitted the little sensor with a nylon fastening and a push-on magnet. So you can't see what's going on. But there you go, the belt driven. Right, okay. I've had a bit of a tidy up over here. Got the computers out. Bought a new mechanical keyboard. I've got two, but I've got another one of these in another room. We didn't have a keyboard for it. This one, this polycarbonate case I built based on an Amiga 2000. I also built a polycarbonate case for an Amiga 500 keyboard. So that goes with that one, and that goes with that one, and the other one goes with the other one. Alright, 3D printed that nice floppy disk drive box. I did a red one the other day to match it. I think I need another one in blue or something. Yeah. I 3D printed different things and push button. Anyway. So that's it. I haven't sold any more switches. So I was thinking about knocking the price down again. Shit. Just to get rid of them. Anyway. Nightmare. Right. That's going to be it for today. Thanks for watching. Oh, I'm going to say it's at 73 yet. 73 all. Bye. Catch you on the next one. Probably be tomorrow in the morning. Just, I don't know. We'll see. Bye for now. Ta-da.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. That information is not available.